Alright, today we're talking about section 6-8, and this is graphing systems of inequalities. This is the very last section in chapter 6. So systems of inequalities are two or more inequalities, and when you graph them, the solution set is represented by the intersection or the overlap of the graphs. Okay, so this is going to be a good time for you to break out your color pencils because we're going to be color coding the two graphs to make sure that we can easily identify the intersection point or the solution set. Okay, so first off, this is example number 1. You have two inequalities, x is greater than 5, y is less than or equal to 4. Okay, so our objective first off is to graph these two inequalities. Okay, for number 1, I'm going to color code this and I'll make the y, the second inequality, red. We'll start off with that. Y is less than 4. Okay, this tells me I always want to write it in slope-intercept form. So y is isolated and you identify the slope. In this case, the slope is 0, and the y-intercept is 0, 4. Okay, so we all remember that when there's a slope of 0, this is represented by a horizontal line, so that's what your graph will look like. Okay, so why don't we go ahead and go to our graph and let's graph this information. Okay, our y-intercept is at 0, 4. So I'm going to go 1, 2, 3, 4. There's our y-intercept, and we set the slope is 0, so it will be a horizontal line. Before I make a horizontal line, I'm going to double check because I want to make sure that the boundary line is correct. So here we had written y is less than or equal to 4. So that tells me that my boundary line is going to be a solid line. Okay, so going back to my graph, it will be a solid horizontal line. Okay, so we have our solid horizontal line. So let's test some points to see which half plane we should shade. Should we shade the bottom or should we shade the top? Okay, so let's test some points. Okay, my favorite point to test, 0, 0. Let's test that origin. If we replace the origin, we have x, y. We're going to use 0, 0. So 0 is less than or equal to 4. Is that true? Yes, that is certainly true. Okay, so what we're going to do is we're going to go to our graph and we're going to shade. Now be very careful when you shade. What you like to do is make a line perpendicular to your boundary line. Make sure it's perpendicular to your boundary line. Okay, so what you have is this bottom region shaded. So that is the graph of y is less than or equal to 4. So I'll write it right here. Y is less than or equal to 4. Okay, now let's take a look at the other inequality. The other inequality is x is greater than 5. Okay, so take a look. For x is greater than 5, I'm going to use blue. And keep in mind, our slope here is undefined. It will be a vertical line. Okay, and it is a greater than symbol, so I know that it's going to be a dotted boundary line. Okay, so let's go to our graph. X is greater than 1, 2, 3, 4, 5, and this will be a vertical dotted line. Okay, if you're using a pencil, what you can do is make a solid line and go back and erase. So this is x is greater than 5. Of course, we now need to take care of our shading. Okay, so let's test a point, and again, I would like to test 0, 0. If you put in 0 for x, so let's see, 0 is greater than 5. Is that true? No, it's not. That is false. So what we're going to do is, you're not going to be shading in the left side, you're going to be shading in the right side. Okay, so let's shade in the right side, and again, make your lines perpendicular to the boundary line. Okay, I'm going to take my red pen now for the line of y is less than 4, if I were to extend this, I would be shading in this section here. Okay, so you can see clearly that your solution set is everything in this section of the plane that's shaded in both red and blue. Okay, so that will be your solution set. Okay. Let's do another example. In this example, y is greater than negative 3 plus 1, and also y is less than or equal to negative 3 minus 2. Again, let's color code this. So let's start off with red. Y is less than negative 3x plus 1. It's already in slope-intercept form, so I can identify that our slope is negative 3 over 1. Our y-intercept here will be 0, positive 1. Okay, so for the second equation, or inequality, we have a slope also of negative 3 over 1, and our y-intercept here will be 0, negative 2. Okay, so we're going to go to our graph, and first with your red pen, going to graph the y-intercept for the red equation, 0, 1, and our slope is negative 3, 1. So down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Okay, let's check. Is this going to be a solid line or a dotted line? Okay, our symbol is a greater than symbol, so it will be a dotted line. Okay, so I'm just going to roughly sketch. You can use a ruler. Dotted line. Okay, now let's test to see where we should shade. Okay, I'm going to test a point over here. This will be negative 2, 0, because I know that this half plane is part of that point. So let's test negative 2, 0. Okay, so let's see. Our equation is y is greater than negative 3x plus 1. So we're going to plug in, this is x and that's y. Let's see if this works. 0 is greater than negative 3 times negative 2 is a positive 6 plus 1. 0 is greater than 7? Absolutely not. So this is false. Okay, so this point over here is not what we're going to shade. We're going to shade to the right. Again, make your shades perpendicular to keep everything neat. Okay. Now let's take a look at our second equation, or inequality. Here we have y-intercept of negative 2. Let's go to negative 2. And our slope is also negative 3. So we're going to go down 3 over 1. Down 3 over 1. And we have the same slope, so we do expect that these lines will be parallel. Let's double check our equation. It is or inequality, it is a less than or equal to sign, so we're going to make a solid line this time. Solid line. And just like the slope suggests, it is going to be parallel to your first inequality. Okay? So now, which side are we going to be shading? Are we going to shade to the right side or to the left side? And let's see. Again, I'm going to pick a point that's all the way over here so we don't make any mistakes. There's negative 1, negative 2, negative 3, negative 4. Let's test negative 4. Okay, negative 4, 0. So your x coordinate, your y coordinate. So we're going to substitute in to the equation. We'll have 0 is less than or equal to negative 3 times x. So that's negative 4 minus 2. Okay. 0 is less than or equal to, multiplying a negative times a negative, I will get a positive, and then I'm going to subtract 2. So 0 is less than 10. This is true. Okay, it is true, so we are going to be shading here on the left side of that boundary line. Well, if you're looking at this graph and we said that our solution set is the overlap or the intersection, we can say here that the solution to the systems of inequality is no solution. Okay, I'm writing this underneath. It's no solution because if you look at the graph, there's no point of intersection at all. Okay? So let's try some on your own. I'd like you to try textbook page 343, number 2 and number 4. Okay? I'm going to go on to example number 3. You can pause the video if you need to try those textbook problems first. Example number 3 is going to be an example of a word problem. A college service organization requires that students maintain at least a 3.0 GPA and volunteer 10 hours a week, at least. We're going to graph these requirements. Okay? So the very first thing we want to do, of course, is to define our variables. Okay, we have to read the problem. What are the variables in this problem? Okay, so we're talking about here GPA and volunteer hours. Okay, so I'm going to let X equal, let's see, GPA, grade point average. Okay, and we will let Y equal the number of volunteer hours. Okay. Then we're going to write our inequality. Said that the GPA has to be at least 3.0. Okay, so our GPA is represented by X is at least, which means that it can be more than 3.0, it can be a 3.0, but it cannot be less. So it has to be greater than or equal to 3.0. Okay. Second equation, inequality. Volunteer hours has to be at least 10 hours a week. Okay, so number of volunteer hours has to be at least 10 hours. Okay. So now that we have our two inequalities, let's graph. Okay, I'm going to write in what the values of X represent. Remember we talked about defining our variables? X represented the GPA. So we're going to label in our X's. And Y represents the number of volunteer hours. Okay, so GPA, we know that at least it's going to be 3. Okay, and I don't think it could be 4 if you're taking honors classes. It could be a little bit more than 4. So realistically, I'm putting 1, 2, 3, 4, maybe 5 at most. Okay, and you're never going to have a negative GPA, so you don't have to graph that side of the equation. We have here a number of volunteer hours, but it has to be at least 10. Okay, so it can be more than 10, but in this particular requirement, it has to be at least 10. So I can go ahead and number all the way up to 10. Okay, so our two inequalities are we had X is greater or equal to 3.0, Y is less than equal to 10. All right, so I'm going to graph the first inequality in red. Okay, it has to be greater than or equal to, so we're looking at a solid line, and solid line right at 3. Okay, so sure. Okay, and let's see, where are we going to graph? We are going to be shading. Let's put in a point. If we put in 0, 0, that's a point here, let's check it, is 0 less than or equal to 3? it is less than or equal to greater, no, it's not less than, it is greater. So that's not true. Okay, so we're going to be shading on the right side. Okay, let's take a look at the second equation, and again we're color coding, so let's pick up our other color. Y is greater or equal to 10. Okay, let's go up to 10 and greater than or equal to, so that again it's a solid line straight across. Okay, so y is greater than or equal to 0. Again, we're going to test point 0, 0. Is 0 greater than or equal to 10? No, it's not. Okay, so we're going to be shading outside. Okay, so again, I'm going to have to extend this line so that we can clearly see our solution set where the red and blue intersect, and it is in this upper right hand corner. Okay. Those are the requirements of this particular college organization. Okay. So now I'd like for you to try in your textbook, page 343, number 5 and 6. Bring that to class tomorrow and we will go over that.